Okay, so we're here with the solutions to the January 2016 Regents exam, Common Core Geometry. So we're looking at number one here, the cross section. You're trying to, this is a little bit of spatial reasoning. You're trying to imagine now, cross section is you're trying to imagine that you're slicing through this 3D shape. Okay, first of all, you got to imagine it's a 3D shape. And then you kind of imagine what kind of shapes you can make with different cross sections. So the square is going to be the one that's not going to work. Okay, there's going to be no slice we can take through this 3D shape that's going to get us a square when we open up and look at it. Now the triangle is kind of tricky because it's a curved surface, but if we could slice straight down with a piece of paper through the point right down through there, what you can imagine is we would get this triangle right here. Okay, so we can get that. As far as this cross section goes, what we would do for a curved cross section is we could slice. Let me see here, get rid of this. And what we could slice is we could go straight through. Whoops. If we sliced straight through like this, in that direction, what we would hit is we'd hit a kind of a parabola, a shape like this that we'd cut off. But then at the bottom it would be straight, and that's where we get the straight part from. And then this this ellipse or oval shape, we're going to get that from going through and slicing at an angle, kind of going through this way. You won't hit the base at all. So what that'll do is it'll give us kind of an ellipse. So that's how we would do that. And again, it's spatial reasoning, trying to imagine what will happen. Okay. Next one, pretty straightforward here. Very nice for us, perpendicular to the line that we look at there. First thing we do is we take that line and we take its slope. So slope, make sure it's just the number, not the x. Okay, so that's the slope of this line. So perpendicular line, we'll need a slope of negative reciprocal, flip it, and change the sign from negative to positive. So that eliminates these two. And now what we have to do is we have to take a look at the graph. Either we could do this algebraically, or I put a graph over here a little easier. Go to 6, -4, and we can start using a slope of up 2 over 1. And of course, we want to hit this way. We want to go in this direction here, and so on. Clearly, it's not going to be a +14 for our y-intercept. It's going to be somewhere in this range, which would make sense with -16. So that's our choice. All right, next, a lot of steps in this problem, but, reasonable here. So first of all, it's a parallelogram. And since that angle is 60, what I like to do with these is separate each part of the problem, break down the problem, makes it a little easier to solve. So first thing we'll do is 180 minus 60. It's going to get us 120. And here's all the angles of the parallelogram. So the purpose of telling you it was a parallelogram was basically to get that right there. Okay. Now we take the next step of this problem, and what we have is a diagonal. The diagonal of a parallelogram does not have to split these two equally. And what they showed us here was SRT, angle SRT. That's this one right here. Okay, so that's 83 degrees. So the next step is 120 minus 83. We're going to get a 37. So this angle right here is 37. Right there is what we're looking at. All right, next step. What we have is this triangle right here that we're going to focus on, WVR. And we're going to need this exterior angle to do this. They gave us this angle's 35, so that's vertical. We're going to put a 35 in there. Vertical angles are congruent. We're putting a 37 in there, right, from this part. And they actually want WVQ, which is this angle. It's an exterior angle. We technically should be using the exterior angles theorem, which is simply the two remote interiors added together will equal the exterior. Of course, there's other ways to do this. So this angle is going to be 72 degrees, and that's what we're looking at, choice 3. So let's see, we have the fish tank in the shape of a rectangular prism. So build a model for it best we can. Let's see, we got 14. They didn't tell us which places to put this, so let's just assume distance across, distance up and back, and up and down is 10. Okay, it does. Let's see. All right, so the tank is not full. Okay, we'll have to see what can it hold when it's full. Right now it has this much, 1,680 cubic inches of water. So the inches are consistent. We always should check that. And then they want which percent of the tank is empty. So that's going to be careful. We're going to figure out how full it is, and then we'll have to subtract. So let's go do that. The volume is going to be base times height from your formula sheet. We know it to be length times width times height. And it's simple. The area of the base is the length times width. So we'll say 14 times 16 times 10. And that is 2240. So that's if it's full. It'll hold 2,240 cubic inches of water. All right. Let's see. Proportions are nice to work with, especially with percents. We'll say percent over 100 equals part over whole. You could go right now, we could go 1680 out of 2240. Just remember, we're going to subtract at the end. We can call that x for now. 2240x 16,800. 168,000, sorry. And divide. We're going to end up with the percent is 75% full. So 100 minus 75, we've got 25% empty. So be careful, little trick there. All right. Let's see, perimeter to be different. We're not going to use a rigid motion transformation. So we're going to change the size, either with a stretch or a dilation. Let's see, this is, that looks like a line reflection, y equals x, so we don't want to do that. This is probably a line reflection over the x-axis. Don't want to do that. This is a translation. And this is going to be a dilation. So that's what we want. We want to change the size. When you multiply both by the same number, it's a dilation. So that's the one we're going to choose here. All right. Okay, FE bisects AC. So these are the same. AB is the same as BC. From that. GE bisects BD. Okay, well, BC is congruent to CD. They're probably getting this. Those two are the same. Nah, they made it DC, but yeah, that's what they're getting at. That's always true. These other things are kind of tricks. So, yeah. They never said that these bisected each other, which is kind of what they're going after on it. Probably a couple of the choices. So, this is the one we want. That's always true. All right, so nice. This is straightforward. It's a volume of a prism. So grab the formula from the formula sheet. whoops. So this part here, this B, remember this is the area of the base. And your pyramids and prisms, they have a base. In this case, the base is the shape of a square. Okay, it's not just a, it's not just a length across. This is a 3D shape. We talk about area of the base. We're talking about a 2D shape here. And so that's going to be a square. All right. So the area of a square is going to be both the sides multiplied together. All right. And then the height is, they give us that right here, 12 inches. All right, so we multiply those together. I think we're looking at 144, if I remember right. Yes, 144. So nice straightforward problem. And there we go. All right, looking at this problem, um, what it looks like to me is a rotation of 180, center at the origin. So I look through the choices, and I don't see any. Okay. One of the things I look at when I do these problems is I look at triangle ABC, and I look at its orientation. Okay, if you go from A to B to C, keep going. The letters are arranged in a counterclockwise orientation. And then you go over to the image and see if it's the same. Now, okay, so D to E to F. You gotta get the, you know, you've got to get the order of the letters from the, oh, right here, sorry. Maps triangle ABC onto DEF. So now you get your corresponding points from that. And they did want us to go D to E to F, and that's also counterclockwise arrangement of the letters. So what we know is there cannot be no single line reflection. And the reason of that is a single line reflection will change the orientation. Okay. Now we could use two line reflections. We could use a rotation. We could use a combination of translation rotation. Um, let's see. If we look through these, I'm going to skip one for a minute. So I have a rotation, then a single line reflection. So we can't do that. You know, the arrangement of the letters isn't going to work. Same thing here. All right. We never know. Oh, 90 degrees. It looks like we got to go 180. So this one's probably out too, but let's just double check here. Now, a reflection over two lines. This is one of the points. This is one of the standards that we had gone over. When you reflect over two lines, okay, so we take A up to here. That's A prime, P prime, and C prime. Okay, what you have right there is the reflection over the x-axis. And then if we go again over the y, that's looking pretty good. We know that when you reflect over two lines, you get one of two things. You either get a translation, and that's when the lines of reflection are parallel, or you get this, a rotation, when the lines of reflection intersect right there. Okay? The center of rotation is where the lines intersect, and the angle is double whatever the angle between the two lines is. So that's why that makes sense here. And we're going to go with choice one. Okay. All right, down to this. Complement of B is A. So that's basically telling us the measure of angle B plus the measure of angle A equals 90 degrees. And what we know from that, this is a pretty straightforward. Once we know that those two angles add up to 90, their cofunctions are equal. So you're either going to get sine of B equals cos of A, or vice versa. You could have sine of A equals cos B. Of course, we can switch these around. Let's see, which one is it? It's not the one with tans, tan, sine. It's this one right here. So that's what we want to look for. All right, number 10. All right, so we have a point at 1, 1. We'll just call that A, and B, 5, 7. And what we're looking for here is we're going to dilate a line. So we always either get the same line or a parallel line. Now we get the same line when the center of dilation is on the line. Okay. The other possibility is we'll get a parallel line if the center of dilation is off the line. So, all right. We might get the original line, so we don't want to throw that out. We might get a parallel line, and we actually could get a line that passes through the origin, but then it would be these two are kind of tied. That's strange. Okay, because if the center of dilation's on the origin, we'll get the same line. So those two probably are going to knock each other out. We're not going to get a perpendicular line. I'm leaning towards parallel, but let's make sure. Okay, so we get the slope either through the formula or counting. Rise over run. All right, the slope of AB. Let's see, we're going to have a run of 6, a rise of, a run of 4, a rise of 6. And it's positive. All right. So let's continue that. We can reduce that. So 3 over 2. So let's go 1, 2, 3, 1, 2. Okay, so it is going to just miss the origin. Just misses. All right, so that's enough space between there that we are not going to get the same line, and it's not passing through the origin. It is going to be a parallel line. We don't have to actually figure it out. That was the content that they wanted to test to see if you knew. So, all right, for this one, we're going to rotate counterclockwise 90 degrees. They didn't even have to tell us counterclockwise. That's assumed. If they wanted us to go a different way, they'd have to say it. But 90 degrees counterclockwise. Okay, so what we're going to do, let's see, is it going to preserve distance? Yes. Rotations preserve distance. All right, they'll stay the same distance from the center of rotation. And they'll also preserve their same length, everything. So, all right. So if we want to go 90 degrees counterclockwise, oh, so we can get rid of the nose. 1, 2, 1, 2. So what this is, A to the origin, that's going to have a slope of 6 over 2. So then we've got to go perpendicular to that. All right, we're going to use positive 2/6. So let's go, we could go this way, but that's the wrong direction. We got to go that way. So 1, 2, 3, 4, 5, 6, 1, 2. So there's A prime. Oh, that's in the wrong spot. All right, get rid of that one. We know this is the answer, but let's go just show it. From B to the origin. All right, B to O. The slope is 3/4. We got to go perpendicular, use a negative 4/3. We got to head this way. So the run is 3, the rise is 4. B prime is going to end up right there, and that should be negative 3, 4. All right, last one. And we'll take a break up the video here. Number 12, halfway mark. All right, area of a sector. So let's see, that's NL. The whole diameter is 6. All right, that's going to give us a radius of 3. And they want the measure of this angle. Okay. All right, so the area of this sector is 2 pi. We got to figure out how big is this angle. Once we get that, I see what we're going to do. Yeah, so let's get this angle. All right, let's get the area of the full circle, which is pi r squared. So we're looking at 9 pi for the full circle. And there's a lot of debates on how to get this. What I like to think of is what portion, what fraction of the circle is the sector. Okay, so 2 pi to 9 pi. We're getting a fraction out of this. So it's 2/9 of the circle. All right, so what's 2/9 of a full circle? It's 2/9 of 360. So that's going to be 40 times 2 is 80. So 80 degrees in here. That angle, that central angle, right, is going to be 80 degrees. Well, it intercepts an arc of 80 degrees. But now, we really want the measure of this inscribed angle. It also opens up to, or intercepts 80 degrees. The relationship here is half. This angle's half of the intercepted arc. So 80 divided by 2 is 40, and we're looking at angle N is 40 degrees. Okay, that's the halfway mark of this exam, and we'll get the other one going here in a minute.